Hey, so not done a video for a little while on National 5, so this is one of the last topics I'm doing just now. This will be part of the Block 5 work, concentrating on quadratics and then trig, and that actually rounds off the whole course. So the light at the end of the tunnel, very much visible. So I've tried to break up the different questions you could get asked. We've got a little complete the square number here. Then we've got sketching quadratics. Then we've got using the quadratic formula, and then we've got more problem solving type quadratic work. So hopefully that covers everything. And again, with all these topics, it's really important, go onto the National 5 website, have a look at the questions, break them up into the different skills that come up. Yeah, it's the same kind of questions because a lot of the skills that the SQ want to test you on, there's ways that the best ways to do that are in certain questions because they can test two or three different skills. So yeah, get used to the type of questions. So that's what I've tried to do here. So let's start us off. We'll zoom in. Here we go. And this is the classic question, the quintessential quadratic question that you will be asked. Express this or quadratic in this form. Now, first of all, the word quadratic. Okay, quadratic just means the highest power is a cubed. Okay, when you go into higher, we'll do polynomials which have got a power 3. Okay, but we're looking at power 2. Now, power 2s will always look something like this. Okay, if that's my x and my y, I will always have something along these lines. Okay, just realised that's the kind of like the Joker, isn't it? The kind of colours of the Joker. But yeah, you'll have a turning point, where the graph unbelievably, turns a point, it changes direction. And sometimes you may find that it cuts the x-axis. We refer to this as the roots of the equation. So they've all got a turning point. Not all of them have roots. You see this one here doesn't have any roots. This one has got roots. This one's got roots. And you may sometimes find it crosses, in fact, it will always cross the y-axis. That is our y-intercept. Okay, so we just extended that on. They would meet them. So that's our three interesting points. Okay, now when we write this in this form, we're not changing the equation. It's the exact same equation, but what we're doing is writing it in a way that makes this equation more useful. So right now I'm looking at this, and this doesn't really mean a huge amount to me. Whereas in this case, it will help us find the turning point. So this is called completing the square. And all we do is we say, right, I've got x squared plus 8x plus 15. And I want to find the complete the square form. So I'm going to look at the first bit in isolation in here. So what I do is I rewrite that like this. It's going to be x squared. Okay, my 15 stays exactly where it is. So this stays the same, and I'm going to rewrite this in this form. And to do that, I just have to half this number. Okay, so I divide that by 2. So that becomes plus 4. So I have now almost completed this square. Now, if you were to look at what I've done, okay, so if I broke out that bracket, I've got x and I've got 4, and I'm squaring it, so I'm multiplying it by itself. That gives me x squared, gives me 4x, gives me 4x, and it gives me 16. Now, that's good. I've got x squared and I've got x squared. Okay, tick. If I was to group my two 4x's, there's 4x and 4x, and that's 8x, tick. However, I have just generated a 16. Okay, I don't want 16, I want 15. So actually, probably the better way to do it really is instead of writing your 15, you say, wait a minute, I've made 16, but I only want 15. How do I get from 16 to 15? How do I make that, oops, falling over there. How do I get from 16 to 15? Well, I take away 1. So now if I break out this bracket and take away 1, I'm right back to where I started. So what some people do is they say, well, you've got 15, that's definitely there, and I'm going to take away 16 because I don't want this 16 that I've made, I just want this bit, and that will still come out as take away 1. 15 take away 16 is take away 1, negative 1. So there's two ways to think about it. I think that's probably the best way, is just saying, how do I get from here, how do I get from my plus 16 to the 15 that I want? will I take away 1? And that's us completed the square. So like, I'll just do another one over here just to see. Okay, so if I said x squared and take away, not 7 actually, that's maybe slightly too much for that 5, take away 16x plus 5. Okay. So you write your bracket out, and you say I'm going to half the middle term, so half that will give me negative 8, half that, and then you say if I break this bracket out, I will end up generating, so I could draw this out, or I could just say, well, if I break the bracket out, I'm going to end up with 64. That'll give me a 64. I don't want 64, I want 5. How do I get from 64 to 5? Well, I would take away 59. Yeah, take away 59. 64, take away 59, give me 5. Okay, so 2 steps in that. Half that middle term, and then your last term is how do I get from this number, which is really the, how do I get from negative 8 squared? How do I get from there to there? How do I get from plus 4 squared to 15? Okay, that's you. Now what this has done is it's rewritten it in a way which makes it easy to find the turning point, and the turning point is these 2 values here. So the turning point for this one is negative 4 plus 1. Okay, so that one, the turning point is doing something like this, negative 4 plus 1, and it's a happy x squared. Apologies if you can hear my phone there. Popular guy, obviously. Or maybe that's someone watching the YouTube channel telling me to shut up. So negative 4, negative 1, change the sign, stays the same. That's not very good. So negative 4, negative 1 is down here, isn't it? So negative 4, negative 1. Yeah. Change the sign, stays the same. So this one, turning point here, say, right, well, change the sign and give me 8. Stays the same, negative 59. So 8, negative 59 is down there. And again, this is a positive x squared, so it's going to be a happy. If there was a negative out here, a negative 1 like that, it would be upside down. It would be a sad face, a minimum turning point. Sorry, a maximum turning point. Okay, that's a minimum turning point because it goes down to a minimum value. This one is a maximum turning point because that's the highest value on the graph. So this would have a negative x squared term. This would have a positive x squared. This would have a positive x squared. Okay, so when you're asked to complete the square, half the middle term, right? They're giving you that form actually, so you don't even have to really remember this. You just have to know that, okay, I'm going to half the 8, put my 4 in here, and then you're saying, how do I get from 4 squared to 15? Well, I'm taking away 1. Okay. And that's your turning point. Change the sign, stays the same. A nice one. So hope that's helpful. That is a classic question. We went over a wee bit of the general bit of quadratics as well. The other phrase you'll hear used about is trinomials as well, which means the same thing. Trinomials means it's got 3 parts. Okay, so 1, 2, 3 parts. You also, don't forget, quadratics could be a difference of 2 squares. X squared take away 19, take away 9. That would still be a quadratic as well. Look something like that. Okay. So that's not trinomial, but still a quadratic. Quadratic's got the maximum power 2. So complete the square, half that middle term, and then how do you get between the 2? The turning point is change the sign, stays the same. Change the sign, stays the same. Change the sign, stays the same. And that's why we rewrite it this way, because it helps us readily identify what's going on. Okay. And you should be able to figure out that that's not a lot of work in 1 mark in there. And this is 2 as well, so not a huge amount of work in here either. But actually, when you look at that, that's a nice 3 marks, isn't it? There's not a huge amount of brain power required. You just have to remember those steps. Okay, so hope that was helpful. And in the next video, we're going to go on to sketching some quadratics.